So, what is a matrix? A matrix is a rectangular or tabular arrangement of numbers. There are many operations that can be performed on matrices, such as addition, subtraction, multiplication, inverse, transpose, etc. etc. So today we are going to discuss multiplication. So let's take an example for matrix multiplication. Let's say I took an easy matrix for now, 1 1 2 2, and I take 2 3 2 3. So now what comes to someone who doesn't know about matrix multiplication? First what comes to their mind is, maybe just like addition and subtraction, we just multiply the corresponding elements. That if I multiply the corresponding elements, I would get 2 3 and 4 6, which is not matrix multiplication. This is another thing known as the Euler product, which we don't need to bother about right now. So I'll take this same example again and I'll show you what is actually matrix multiplication. So what we do in matrix multiplication is that we start with the first matrix and we take the first element of the first row, that is 1 over here, and multiply it with the first element of the first column of the second matrix. So we multiply 1 with 2 over here, which gives us 2, and we add it to the multiplication of the second element of the first row of the first matrix to the second element of the first column of the second matrix. This is getting too complex. Just remember that it's this into this plus this into this. 1 into 3, that is 1. Now for the second element, we multiply the elements of the first row of the first matrix with the elements of the second column of the second matrix. So we go like 1 into 2 is 2 again, and 1 into 3 is 3. For the third element of the resultant matrix, we multiply the elements of the second row of the first matrix with the first column of the second matrix. So it's 2 into 2 is 4, and 2 into 3 is 6. Similarly, for the fourth element, we multiply the elements of the second row of the first matrix with the second column of the second matrix, which is 2 into 2 is 4 again, and 2 into 3 is 6. So now we add it all up and we get 5, 5, 10, 10, which is a 2 cross 2 matrix. Note that this was also a 2 cross 2 matrix. This was also a 2 cross 2 matrix because it had 2 rows and 2 columns. This one also had 2 rows and 2 columns. And here we also have 2 rows and 2 columns. Now let's take the example of a 3 cross 3 matrix, which will have 3 rows and 3 columns. We'll take a simpler example for a 3 cross 3 matrix, otherwise the calculation could get a bit tedious. So I'm going to take a simple example over here, 1 1 1. And let's say I'll take 1 2 3 4 5 6 7 8 9. Note that this is a 3 cross 3 matrix because it has 3 columns and 3 rows. This is also a 3 cross 3 matrix because it has 3 columns and 3 rows. So this is a 3 cross 3 matrix. This is a 3 cross 3 matrix. So now the resultant would be simply just like we did for the 2 cross 2 matrix. We are going to multiply the elements for the first element over here. We're going to multiply the elements of the first row of the first matrix to the first column of the second matrix. Is 1 into 1 gives 1, plus 1 into 4 gives 4, plus 1 into 7 gives 7. I'm gonna lag a little bit of space here, but doesn't matter. For the second element, however, we're going to multiply elements of the first row of the first matrix with the second column of the second matrix. So this will be 2 plus 3 plus 5 plus 8. And now for the third element of the resultant matrix, we are going to multiply the first row with the third column of the second matrix. So this will give us 6 plus 3 plus 9, which is equals to 18. And now for this element of the resultant matrix, we're going to take this row and multiply it with this column. Similarly, then for this element, we're going to take this row and multiply it with this column. For this one, we're going to take this row and multiply it with this column. So we'll just do that quickly. 1 plus 4 plus 7, 2 plus 5 plus 8, and 18. Similarly over here, for this element, we're going to multiply this row with this column. For this element, we're going to multiply this row with this column. And for this element, we're going to multiply again this row with this column. So it will be 1 plus 4 plus 7, 2 plus 5 plus 8, and 18. So we'll get the resultant as 12, 12, 12, and 15, 15, 15, and 18, 18, 18. Now this is again a 3 cross 3 matrix because it has 3 rows and 3 columns. Now one interesting property we'd like to note over here is that we need to make there's this thing we need to make sure of before we can multiply matrices. You just can't multiply any two matrices together. Like for example, you can't multiply 1, 2, 3, 4 and 2, 3, 6, 1, 2, 3 together. Because the reason is, for the first element, or this element over here, we're gonna have to multiply the elements of the first row with the first column. But the problem over here is, we don't have a third element to multiply with the third element of the first column. So hence we can't multiply these two matrices. Therefore, there's a really important property that we need to note, that if we are taking a m cross n matrix which has m number of rows and n number of columns, then the other matrix which we have to take should have the same number of rows as the columns in the first matrix. So basically this should be another matrix which I'll call B n cross P. Only then will we get a resultant matrix which will be m cross P. C would have m rows and p columns. Now over here we couldn't see that because I took all of them as square matrices. So I'll take just a simple little example more. I'll take 1, 1, 2, 2, and I'll take 2, 3, 4, 6, 0, 0. This is a 2 cross 3 matrix. Because it has 2 rows and 3 columns, this is a 2 cross 2 matrix. Now we can multiply them both together because the number of rows over here is equal to the number of columns. So the resultant will come out to be 1 into 2 plus 1 into 3, which is 5. Then 1 into 4 plus 1 into 6, which is 10. Then 1 into 0 plus 1 into 0, which is 0. Over here, we'll get for this element, we're going to have 2 into 2 plus 2 into 3, which is 10. And over here, we are going to have 2 into 4 plus 2 into 6, which is 20. And over here, we're going to have 2 into 0 plus 2 into 0, which is 0. So this gives us a 2 cross 3 matrix because it has 2 rows and 3 columns. Now we can see that why. This was the number of columns and this was the number of rows. These two are equal. So now we're going to have a matrix which is 2 cross 3. So now let's just quickly discuss the properties of matrix multiplication. One most important property is that they're not commutative. That means A into B will not be equal to B into A. I'll take an example for that. 1, 2, 3, 4, 4, 3, 2, 1. These both can be multiplied because this is a 2 cross 2 matrix and this is a 2 cross 2 matrix. So the number of columns over here is equal to the number of rows over here. So we can multiply that, and that will give us 1 into 4 plus 2 into 2, which will give us 8. Then 1 into 3 plus 2 into 1, which will give us 5. And 3 into 4 plus 4 into 2, that will be 12 plus 8, which is 20. And 3 into 3 plus 4 into 1, which will give us 13. So this is a 2 cross 2 matrix. Now let's try the other way around, okay? 4, 3, 2, 1. This is again the same matrix over here, and this is the same matrix over here. 1, 2, 3, 4, 2 cross 2 again. So now we're gonna have 2 cross 2, 4 into 1 plus 3 into 3, which is giving us 13. 4 into 2 plus 3 into 4, which is giving us 20. 2 into 1 plus 3 into 1, which will give us 5. And 2 into 2 plus 4 into 1, which will give us 8. Now clearly we can see that the corresponding elements of these two matrices are not equal, hence these two matrices are not equal. So the next property we have is associativity, which is A multiplied with B, C is equals to A multiplied with B and then multiplied with C. This can be easily verified. And the next property is distributive, which is A into B plus C gives AB plus AC. This can also be easily verified. So I think that's the end of that. Thank you very much for watching.